Okay, so carrying on from the moments questions, the balancing the moments, beam reactions questions that we were doing. These are beam reactions. What we're going to do is we're going to do more of these beam reaction questions, but the next set of questions, so they're exactly the same, mathematically they're exactly the same, but the difference is we start off in a context this time, so you need to create an appropriate three body diagram before you can do these questions, right? So I'm going to do one, and then I've got 4 questions for you to do there, 3 with context and one's just another normal question. So how do we do it? So what you do is you look in the diagram. Our three bodies are always going to be based on simple flat beams, alright? So you're always going to start off with a horizontal line, and then you're going to add your vectors representing forces onto it, and then your distances, okay? So let's put our forces on. So we've got this 4 kilonewtons and this 60 kilonewtons acting on the beam first of all. So there's a 4 and then a 60. And then we've got our reactions that are sitting here. RA and RB. So that's like an appropriate layout. We can then put our magnitudes of those forces on there. So that's our 4 kilonewtons. That's our 60 kilonewtons. That's our RA. That's our RB. And then we put our distances on it. The distances are 4 meters, 1.5 and 1.5. Yeah, so you need to be able to create that three body diagram. So you end up with something that you can work around. I'm just going to group that and move it over. And then we can do the maths of it, and the maths is just exactly the same as we did in the previous questions. So let's calculate RA first. RA is probably the easiest one to do because all the distances come from RA. So if we go taking the moments, so clockwise moments around RA must equal the anti-clockwise moments around RA. So assuming that RA is our fulcrum, RB is the only unknown one. So what's going anti-clockwise is that 60 kilonewtons. So we're going to go 60,000 multiplied by its distance to the fulcrum, which is 1.5. And that's the only clockwise. All the other ones are anti-clockwise. So that must equal RB multiplied by 3, because that's its distance to the fulcrum, 1.5 plus 1.5, plus 4,000 multiplied by 4. Let's work that out. What's that going to be? 90,000. 1, 2, 3 equals 3RB plus 4 times 4,000 is 16,000. Put that 16 over the other side, so it's going to be 90,000 minus 16,000 equals 3RB. 1, 2, 3 minus 60, 1, 2, 3, 74,000. 1, 2, 3 equals 3RB. So RB equals 74,000 divided by 3 equals 2, 4, what was that? 666.7 newtons. So that's RB. Obviously we would have to round that to the correct number of significant figures. 2, 2, 2, 2, 2, everything's 2. So that's 25 kilonewtons. To 2 significant figures. And then we could do our sum of the ups must equal to sum of the downs. So we're going to have RA plus, remember and use the unrounded figure, 24666.7 equals 4 plus 60. So RA equals 64 minus, oh that's 60,000 there, and that's 4,000. So that's 64,000. Start mixing up your units now. For goodness sake. Minus 24,667. No, 666.7. So that equals, so 64,000 minus 24,660. Oh, my pen stopped. Oh, there it is. Yeah, right, okay, so 64,000 minus 24,666. 39,333.3. Newtons rounded to 2 significant figures, so that's 39. Kilonewtons to 2 significant figures. So you can see how these questions end up exactly the same, but you just have to strip, you have to create your own free body diagram, and as I've said, you're just looking for a straight line between 2 points where your reactions are going to be, and then your distances. Just make sure you get your distances right. So you guys are going to go ahead and complete these questions. What I'm going to do is I'll just zoom in on them, and you can pause the video in order to do the question. Alright, so you can see you've got this structure here, flat beam, 2 reactions. Be careful with this question because this has got that's essentially 2 different questions. You do a suitable free body diagram for this, and then you complete the question with this data in it, and then you'll have to do another free body diagram for part C because it's different. The cart has moved, right? So be aware of that. Also be aware that the cart itself has a weight, and then the cart itself is carrying 2 different weights in the question, so you'll need to do a little bit of addition there. Question 2 is this one. So question 2, again, you've got this big dump truck, and there's 2 questions in here. You have to do a question when the dump truck is empty, and then a question when the dump truck is full. Okay, you know you can just represent the dump truck as the connection between the 2 axles. Remember, you're just looking for a flat line with 2 reactions in there. And question 3, it's a little bit more complex. This one might confuse you a little bit. It is only 1 question though. You know, there's a little addendum in there. How could the arrangement be altered to give a bigger clamping force? The clamping force is what happens at A. So you've got a nut here, and as you tighten that nut down, you're essentially providing a downwards force at B that is reacted to at A and C. And the question is, how could you make the part C, after doing the whole thing, there's your flat beam with your downward force and your 2 reactions, how could you increase that force? What could you do? And what I would say is, it says altering the arrangement. It's not talking about tightening that nut up. Could you come up with another way of increasing that force? And then the last question is just a straightforward beam reactions. You're given the free body diagram, you go ahead and do it. So you can go through those 4 questions and pause it, and that lets you do those questions. Fantastic. Next one.